do a job right and to do it safely, you need the right tools. That's true on Earth, and it's especially critical in space. Hi, I'm Dr. April McDougall, an infection control specialist and travel medicine physician with UTMB Health. The development of those essential tools is the topic of today's Thought Leaders Lecture, preparing our astronauts with the specialized equipment they need to get them to the moon and back and beyond. In medicine, the public had a recent crash course on the role personal protective equipment, PPE, plays in keeping everyone safe. The right gear saves lives and allows us to continue to work efficiently. The same holds true in space exploration. Space can be unforgiving, and astronauts need every advantage. The team speaking to us today will share how they're modernizing equipment like spacesuits that have had very few updates since they were developed in the 1970s. Joining us tonight are Mark Greeley of Axiom and Laura Kearney of NASA. Axiom was recently awarded the design contract for the new spacesuit and boots to be worn by astronauts returning to the moon as part of the Artemis mission. Greeley, who's had an extensive career in aerospace, is Axiom's ex-EVA's program manager, leading the company's efforts to develop next-generation spacesuits to support the Artemis mission, as well as future commercial customers traveling in low Earth orbit. Laura is a biomedical engineer with 29 years' experience in building, testing, certifying, and operating human spaceflight hardware. Her role with Artemis is to ensure astronauts have safe, reliable, and effective systems and equipment, like spacesuits and boots, to work on the moon. UTMB is honored to sponsor the Thought Leaders Lecture Series for Space Center Houston. We hope you enjoy tonight's presentation.
Thank you for joining Space Center Houston's Thought Leader Series program, Artemis Moonwalking Spacesuits, presented by University of Texas Medical Branch. I'm William Harris, President and CEO of Space Center Houston. We're a space exploration learning destination dedicated to bringing people and space closer together. We also have the privilege of serving as the official visitor center for NASA Johnson Space Center. We share the story of human space exploration, past, present, and future. Our Thought Leader series brings you space and science experts from across the country to provide insights and perspectives on space exploration. Space Center Houston curates experiences that reveal how science and humanity power space exploration. We're going back to the moon. The Artemis I mission has successfully launched and is enabling critical research to prepare for a return to the moon for the first time in 50 years. Artemis is the first step in the next era of human exploration. NASA, along with commercial and international partners, are working to establish a sustainable presence on the moon as we prepare to send humans to Mars. The Orion spacecraft launched atop the most powerful rocket in the world, the Space Launch System, or SLS, and began a 25-day, 11 hours, and 36-minute mission. We're excited to share more with you about the Artemis program in today's program. NASA and Axiom Space are working to design a next-generation moonwalking spacesuit. This new suit will enable us to navigate the challenges of Artemis III and beyond, enabling astronauts to conduct research on the surface of the moon to surviving the radiation levels on Mars. These new suits are critical to the future of human space exploration. In our discussion, we'll learn about the Artemis moonwalking spacesuits, which will return astronauts to the surface of the moon for the first time in 50 years. I'm delighted to welcome our panelists for our November Thought Leaders program, Artemis Moonwalking Spacesuits, presented by UTMB. Our first presenter is Laura Kearney. She's an executive with hands-on experience in every phase of the flight hardware process. Laura is NASA's Johnson Space Center's manager of the Extravehicular, or EVA, and Human Surface Mobility, HSM, program. Her responsibility is to execute safe EVAs throughout the life of the International Space Station and develop EVA and HSM systems for Artemis to provide crew exploration capability on the moon. Laura has held various roles with Johnson Space Center. She served as the Deputy Program Manager of the Gateway Program, Crew and Surface Module Manager of the Orion Program, and Manager of the Extravehicular Activity Systems Project within the Constellation Program. Our next speaker is Mark Greeley. Mark is an experienced leader and program manager with federal government contracts and the public sector, including interface with state and local entities. Mark Greeley is currently leading Axiom's spacesuit program. Mark has over 30 years of experience managing NASA's Space Shuttle and International Space Station launch, entry suit, and extravehicular spacesuit programs for Boeing, United Space Alliance, Stinger-Gafarian Technologies, KBR, and Axiom Space. He was the former program manager for the Space Shuttle Crew Escape Program, Extravehicular Systems Contract, Flight Crew Equipment Extravehicular Activity Program Element, an Extravehicular Space Operations Contract, and the Research Engineering Mission Integration Contract. Well, that was a mouthful. Welcome to our two panelists. So excited to have you here today. And first, we're going to hear from Laura.
Thank you, William. Really excited to be here with you today. I'll give you a little bit of an overview on the Artemis program and our program, the Extravehicular and Human Surface Mobility Program at JSC. So it's a really exciting time to be part of the space program. We are returning to the surface of the moon, but we're going differently this time. Instead of a couple weeks excursion at a time, we're going to stay. So our goal is for Artemis III to land on the moon in the 2025 timeframe. And in doing so, we intend to land the first woman and person of color on the surface of the moon. This time we'll be going to the lunar South Pole, where we're interested in finding water ice. And this time we're going with a lot of partners, both domestic industry partners and international partners. And while we're there and we're learning how to work on the moon for long periods of time, we'll be preparing to go farther onto Mars. So as I mentioned, this is a very collaborative effort this time. We're including a lot of domestic industry partners across the United States of America and many international partners. As you may be aware, NASA is frequently adding international partners to our Artemis Accords. These Artemis Accords describe our shared vision for the principles for returning to the surface of the moon. They help create a safe and transparent environment which facilitates exploration, science, and commercial activity for all of humanity to enjoy. So how are we going to execute such an exciting Artemis program? As William mentioned, I'm excited to say Artemis I is flying today. I was actually at the launch on November 15th and really excited to see it myself. Artemis I is the first launch in the overall Artemis program. It is an unmanned spacecraft, but it is going farther beyond the moon than any other human-designed spacecraft has in history. It will soon be followed by Artemis II. We will fly the very first humans in the Orion spacecraft. Soon after that, the Gateway will launch. The Gateway is an orbiting platform that will circle the moon, sort of like a mini space station. The first elements of the Gateway will be launched in the 2025 timeframe. Once that vehicle is on orbit, we will then use the Gateway for our longer duration lunar surface missions. There's even a longer term plan for Artemis beyond that. Once the Gateway is delivered, we will start to see the lunar surface systems. The spacesuits will first show up for the Artemis III mission. We have a lunar terrain vehicle, which is an unpressurized vehicle, which is targeted for Artemis V. And we have a pressurized rover, which is currently targeted for Artemis VII. And all of these systems will come together in this decade to execute exciting lunar missions. So I am really excited to manage the EVA and Human Surface Mobility Program. The elements I've already mentioned to you, the surface suits, the lunar terrain vehicle, and the pressurized rover, we have brought them all together under one program infrastructure. And we did that because we know these elements need to work together seamlessly on the surface of the moon. So we can make sure that the requirements are working together across these elements, as well as the operational capabilities and all of the scientific utilization objectives. We also have the space station suits in our program because we are really looking to take all of the lessons learned for operating spacesuits and executing EVAs from our many years on the space station and taking them forward in how we operate and perform EVAs on the lunar surface. The new suits that we are developing for Artemis will also be used on the International Space Station. The current EMU that is on board Space Station has been operating for quite some time, and so we're looking to upgrade it to the new suit capability in the 26 timeframe. So our new suits, we're going to bring in a lot of new capability. We have an extended anthropometric range, meaning we can fit small women up to larger men. So we can fit an entire range of anthropometric sizes that come from our international crews. We'll be able to stay longer on the surface because we have a lot of technologies that don't require us using consumables that we have had to use in the past. We'll also have a lot of advanced technology tools that will allow us to collect lunar samples and bring them home. We are really excited to say that we have awarded our new suit contracts to 2 contractors, Axiom Space and Collins Aerospace, and we will all be working together to develop these new suits for both the International Space Station and for Artemis. The Lunar Terrain Vehicle is unlike the rover that we used in Apollo. You can see the visual down here on the bottom of this chart. We think of it similar to a combination of an Apollo rover and a Mars rover. Unlike the Apollo rover that the crew used for 2 weeks at a time, this rover will be on the surface for 24 hours a day, 365 days a year for up to 10 years. So when the crew is there, they will use it as a mechanism to be able to extend their exploration range farther than they could walk on their own. But while the crew is not there, it can be used for scientific exploration. We will be able to operate it telerobotically, either from the other lunar assets or from Earth. And that way we get use out of the system when the crew is not there. And our final element, the pressurized rover, will allow the crew to expand their exploration range even farther. It should support 2 crews for anywhere up to from 14 to 30 days and be able to travel from 600 to 1,000 kilometers. All of this is being done to be able to explore the lunar surface farther than we ever have before. We're currently working with our JAXA partners to establish an international agreement for them to provide this rover service. As I mentioned before, our program also supports the International Space Station. Spacewalks are very important to make sure that the space station is maintained in a safe and healthy condition. And so we will be using these new spacesuits to support those EVAs on the International Space Station. So we are really excited to be heading back to the moon, and we're excited about the role that our EVA and HSM program plays in making that effort a success.
Thank you so much, Laura. That was so interesting. I can't wait to get into our Q&A discussion because I've got a lot of questions about the new suits. And it's so interesting that they are both used for EVAs on space station, but also for lunar exploration. So that's going to be really interesting. I'm now delighted to hear from Mark Greeley from Axiom Space, and we'll have questions and answers right after that.
Thank you, William. Well, first, we're delighted to work with Laura and her team. It's an honor and a privilege to build the spacesuits that are going to go back to the moon as part of Artemis. A little bit about Axiom Space. So Axiom's mission is to improve life on Earth, foster new possibilities beyond, and build and operate the world's first commercial space station. We were established in 2016, and our mission is to build the first commercial low Earth orbit space station, which will be accessible to governments, researchers, manufacturers, and individuals. We competed for a full and open contract, which gives us the privilege of connecting our Axiom space station modules to International Space Station, which will help ready us to complete our space station on orbit. Axiom intends to build a space station in 3 phases. The first phase is to lay the foundation for commercial space. And we're doing that by sending private astronauts to orbit, and they conduct research on the International Space Station, mostly 10-day missions, but it's all in preparation for our subsequent phases. Phase 2 is to complete our module launches. So we're on track to launch our first module in 2025. This will be a crew quarters and research and manufacturing module. Subsequently, we'll launch an expanded crew quarters module with a larger research and manufacturing module. And then lastly, we'll launch a power tower, which includes all the thermal and power we'll need to complete our build out. Phase 3 is the point at which Axiom becomes an independent space station. And prior to NASA decommissioning the International Space Station, we will be ready to deorbit and become the first low Earth orbit commercial free flyer space station. Axiom supports a pretty diverse number of markets. We support human spaceflight, commercial on-orbit services, and deep space exploration. Human spaceflight includes the private astronaut missions I mentioned earlier. Commercial on-orbit services include research in space manufacturing, education and outreach, and brand and media partnerships, much like NASA's current International Space Station. Deep space exploration allows for a low Earth orbit platform to conduct testing, integrated testing, any human performance studies, develop technologies, mature technologies, and then near and dear to me is our next generation spacesuits to support the Artemis lunar missions, and then the spacesuits for NASA's commercial customers. So Axiom, we're building history by developing the next generation spacesuits to support the Artemis lunar missions. And then Axiom's next generation spacesuits will support lunar missions and future Axiom commercial customers. So Axiom Space, a new commercial space company, has made incredible progress toward commercial space and EVA. And we would love for you to follow us as we build history in low Earth orbit and on the moon. Thank you.
Great, thank you, Mike, and thank you, Laura. What a fascinating presentation to give us an orientation of what's going on. This really is a new approach in collaboration between NASA and the commercial sector. And I know the commercial sector has always worked with NASA, but it's fascinating that you're developing products for NASA, but also for private customers. My first question is, as you develop the spacesuit for the South Pole of the Moon, are there any special considerations? Because we know that the sun kind of skims the South Pole and you have extremes of heat and cold. Are there any kind of special considerations in developing the spacesuit for that environment?
Yeah, definitely the South Pole is very different than our last trips to the moon. We've had to incorporate improved insulation for the colder environments at the South Pole, and increased lighting, so we can see crew.
So I'm curious as well, kind of staying on the theme of the South Pole and the challenges that it presents. You know, during the Apollo program, the missions were fairly brief. You know, the early missions were a matter of hours and then a few days. Now I know the plan is for longer duration missions on the surface of the moon. What are some of the considerations in the design of the suit that you're having to look at if humans are going to be on the surface of the moon for more than a few days?
And first, let me start by saying we're using NASA's XEMU technologies, and we're building on that platform. So NASA did an incredible job with XEMU, and it was a great foundation for Axiom to add our technologies to the suit. But things like mobility, safety and redundancy, and as Laura mentioned earlier, ensuring that we can accommodate a much larger population of crew. first to 99th percentile, which is a pretty significant achievement.
So Laura, I'm curious. It's fascinating that you're looking at an EVA suit that works both on space station but also on the surface of the moon, because my first impression would be that maybe there are different requirements because you have to walk on the surface of the moon and maybe have soles or something that are more sturdy than an EVA because you're generally using your arms. How is this suit being designed to meet both requirements, to work for ISS as well as the surface of the moon?
Yeah, that we really thought about it on the NASA side before we put the requirements set out for competition. And we looked at the requirements for both the space station platform and the Artemis platform. And you're exactly correct. On the lunar surface, there are some unique requirements that come with being in the gravity field, also being in a dusty area. So that is unique to being on the surface. But the good news is the life support system is predominantly the same, whether you're in low Earth orbit in a zero gravity field or in a partial gravity field on the moon. The life support technologies and what you need to keep a human alive is really the same. So although there are some requirements that are unique to the lunar surface, the vast majority of them are the same. And so we did deliberately, when we put the requirements set out for competition, said we wanted industry to bid to bring forward a proposal that met the requirements for both platforms, because we knew that was going to provide us some backup capability and some inherent redundancy in the system between the station and the lunar surface.
So I'm curious, what are some of the significant differences between the Apollo spacewalking suits and the suits that are being developed? I remember seeing footage of Apollo astronauts in the moon, falling, jumping, tripping over things. It seemed as if, they didn't have a chance to test the suits on the surface of the moon before going there. They did some simulations, but it seemed like the suits presented some challenges. I know they were also very excited and trying to get around as fast as they could. And also they'd not been 1/6 gravity before, but what are some of the significant design differences between the two suits?
I would say one of the biggest one is the mobility. A lot of what you saw in Apollo when they were falling over, the suits were not very mobile. And so we have really learned a lot over the decades about mobility joints, be it in the knees, the shoulders, the waist. We use mechanical bearings now so that the crew members can get a wider range of motion in a pressurized garment. When you pressurize that suit, it really becomes a hard balloon, and it's very difficult to work against that pressure. And so the mobility elements that we have added have increased greatly over what they had in Apollo. I would say probably the second big one is in the consumables. We have technologies now that are actually regenerable, so we don't consume the same amount, say, for carbon dioxide scrubbing as we did in the Apollo era. And so every pound of mass that we can save by not having to fly consumables helps the overall Artemis program. And then, of course, just we as society have made huge advancements over the years in everything electronic. So as Mark mentioned, we have redundancy in our systems because things are smaller than they used to be. The electronics, the software is more reliable than it used to be. So overall, the suits are just generally safer and more reliable than they were 50 years ago.
So Mark, it was fascinating to hear about the vision for Axiom and the future space station that you'll have. Do you anticipate sending private astronauts to the moon?
Not at the moment. At the moment, we're focused on LEO for Axiom and then lunar for NASA.
And so will the training with this new spacesuit be less onerous than the previous suit? It sounds like it is much more ergonomic and perhaps easier to understand how to work within it. And I've had the fortune for an exhibit we paid there at Space Center Houston, where we had a glove from a spacesuit that you could pressurize. And it was so hard to try to pick up an object with that pressurized suit. So I think it'll be great to have these new suits that are more facile to use or more adaptive. Will it require less training for, say, for private astronauts?
For private astronauts, we have crew that fall in two categories. We have professional astronauts that will conduct EVAs, to do something outside of our space station, and then we'll have EVAs that are more related to commercial astronauts that simply want to do an EVA, go outside and have the experience. For task-driven EVAs, most certainly they will go through the same rigor that we would put any astronaut through to be prepared for their EVA. For a commercial EVA that's not task-driven, it would certainly be less onerous. It would be more familiarization with the suit, what the environments are, things of that nature.
That is amazing to think that private astronauts will have the opportunity to do some type of EVA. I know when I talk to a lot of constituents, people are very excited about the possibility of going to space, non-astronauts, and to do an EVA would be an extraordinary thing for someone. That's really quite remarkable. Laura, I wanted to ask you about the rovers. I'm presuming the pressurized rover means that once inside, the astronauts can remove their spacesuits. Is that correct?
That's exactly right. Yeah, the whole idea is that the crew can travel on the surface in a shirt sleeve environment. And then once they get to a location that the scientific community has identified as being high interest, or even if the crew looking out of the windows has identified something of high interest, then they would get in their suits and do an EVA. So again, it allows them to go much farther away from the lander or a base camp than if they were just walking or on an unpressurized rover. So they would sleep in it, they would exercise in it, they would eat in it. It would basically be like being in a little mini RV on a short camping trip.
So I'm curious, what is the propulsion system? I was fascinated to hear about the LTV and how it's both a independent rover that with commands from mission control on Earth, but also can be used as a transport vehicle for astronauts. Would it be electric fusion or would it be solar? Is there an idea yet what the propulsion will be?
Yes, so we have looked into that on the NASA side. We actually just released a draft request for proposal for the LTV to industry, and we are waiting for feedback on that draft RFP. Similar to the approach we took with the spacesuits, we are not dictating particular designs or technologies, and so we're really looking forward to the innovative solutions that we see from industry. But the NASA analysis tells us that in the lunar South Pole area, where, as you mentioned, we have these really kind of shallow shadows and we can be in the dark quite often, it's probably going to take some combination of perhaps solar electric capability, batteries, and potentially even fuel cells. So like I say, we haven't dictated. We're curious to see what industry brings back to us in their innovation.
So from an aesthetic perspective, spacesuits, of course, have to be designed first and foremost to fulfill functional specifications. But do you take into account the aesthetics? Do you look at the color or beyond the functionality? Is that one of the questions that you ask or that you explore when you're designing a suit or looking at a suit for astronauts?
Yeah, from a NASA perspective, we really have thought about it more from a functional perspective than an aesthetic perspective. Of course, the white is a reflective material, so that can help. It's not an EVA spacesuit, but the suits that we see or we saw our shuttle astronauts launch in, say they were orange, that was there because in case they had to bail out of the spacecraft in the water, they would be easy to find. So we have historically looked at it more from a functional perspective than an aesthetic perspective. But it's also a new world order. And I know, you know, with the commercial companies and in talking about having commercial participants, I'm sure the aesthetics will start to come in more than they have in the past.
So from the commercial perspective, certainly the NASA suit will be white because of the reflective properties necessary. But on the commercial side, we will have we have engaged designers that are working with us on the final look of the EVA commercial spacesuit.
That's very interesting because we now live in the world of branding, right? And it's really important. And actually, NASA has been very successful. The NASA meatball, as it's referred to, is one of the most recognized logos in the world and is associated with exploration and innovation. So I can understand how that could be very, very significant. So what kind of skills and background or training is required to be part of a team that's developing EVA suits? I'm curious from both of you. Laura, maybe starting with you, what are you looking for in your team members who are helping you advance these technologies, both for the spacesuits and the rovers?
Gosh, we look for all kinds of expertise and background. I kind of think, you know, I start high and come down. We love systems thinkers, people that can think big picture, starting with operational capability, learning about or knowing about the environments, because that's where the requirements come from, is people that can think big picture, the overall mission overview, and can take those kinds of concepts and distill them into a physical requirement set for a spacesuit. Then, of course, there's the actual designers, and so it's mechanical designers, electrical designers. With the spacesuit, it's soft good fabricators that we don't see in other industries, thermal analysis engineers, software writers. So really any engineering field that you would see in a spacecraft, you would generally see in a spacesuit. It's just a kind of a smaller version. And then, of course, it's, you know, it's on all of us to make sure we are trying to deliver these products on schedule and within a budget. So we have budget analysts, we have schedulers, we have project managers, folks that make sure we keep such a difficult technical challenge within the programmatic constraints that we've been asked to operate.
And Mark, how about you? What are the skill sets that you're seeking for your team members?
Yeah, I would say everything that Laura just described is the same for Axiom. We have been very lucky. We've hired a large number of former XCMU designers, systems engineers, you know, fabricators, technicians, all very helpful because they have relevant experience, and they came into Axiom able to work on day one, didn't require a lot of training because of their background and their experience.
Well, I think you both are very creative people for what you have to think outside the box. Even though spacesuits have been around for decades, how to innovate them. Where do you draw your inspiration? What helps you innovate or think of new ways of modifying existing suits or creating new aspects of suits? You know, are there places that you go to or things that you look at? I know a lot of industries use nature, right? Models in nature as a way of inspiration. I'm just curious if either of you could share what inspires you.
I'm pleased you think of me as creative, because I don't think of me as creative. You know, I think it's funny. I think we see a lot of it, honestly, from movies, from Hollywood, because they don't live within, you know, the engineering constraints that we necessarily do. I think we learn a lot from the diving industry, right? They have very similar challenges to what we face in spacesuits in space. I think, to me, you look at these entrepreneurial companies that just can do things much quicker, much faster without a lot of, say, the processes that we have created within NASA. They can just innovate much quicker through 3D printing, although we use that on the NASA side now too, but they can innovate very quickly with just their new ideas coming from commercial industry.
Well, how about you, Mark? What provides you with inspiration?
Well, I think working for my team is what provides me with inspiration. It's amazing to watch, this diverse team made up of a lot of highly experienced personnel and some younger generation personnel come up with new ideas and innovate, and they're unconstrained by much of anything. They're free to think and free to design and offer solutions where we think we have some technical challenges, and it's just an amazing thing to watch all these young engineers in the program work so hard to build this new suit.
So a little bit about each of you. How did you get to where you are today? I mean, we've read your bios, but did you imagine as children that you would do something in engineering or something related to space exploration? What were your early designs on a potential career path or future? How about first from you, Laura?
Yeah, I actually have to admit, I was not one of those people that had the childhood dream of working at NASA. I actually am a native Houstonian and grew up in North Houston here. And as a child, did not even know Johnson Space Center was in my backyard. It wasn't until I got to Texas A&M. I'm a biomedical engineer. And it wasn't until JSC came up to recruit at A&M that it dawned on me that biomedical engineers worked in the space industry. I figured I was going to be somewhere with medical equipment or something like that related to the medical industry. I had even toyed with medical school. But I always had a fascination with space. I remember being a child and watching the later Apollo landings. I always had an interest in the stars and the planets and things like that. I just had never really thought about working at NASA. But once I got here in 1992, I guess it is, I have been here and just could never leave this environment because I'm so inspired by what we do, so excited about what we do. As far as my interests, I migrated towards project and program management very early in my career. I really enjoyed building teams and leading teams and watching teams execute really hard missions. I'm also, I love the budget, I love the schedules, I love the risk management. So I migrated to project management really super early in my career.
Oh, that's fascinating. How about for you, Mark?
Similar to Laura, I'm a farm kid from Minnesota. NASA wasn't even in my sights. Wasn't until I went to school and joined the Air Force. In the Air Force, I worked on a high altitude program that used launch entry suits, and that's what brought me to Houston. That's where my inspiration came from. I've always been intrigued by NASA, but I just never saw myself ending up at JSC, and been very blessed, able to manage many programs that supported NASA, and so this is probably the cherry on top for me. This is the highlight of my career.
Well, that's terrific. I think it's so important for people to hear that some people are inspired from the time they're children, and others not until later in life, until some other opportunity presents itself. And I'm curious about, because you both are senior managers, you're both, I know, actively recruiting people for your teams. What advice would you give to young people watching this program if they're interested in a career either at NASA or Axiom or the commercial sector? What would you encourage them to study or learn about or be involved with?
Yeah, for me, I like to tell the younger folks, recognize that there are multiple ways to get to a destination. I think as long as you know what your end goal is, you have to have some flexibility for how you get there. You may set out on that goal and you hit a little road bump. You may have to adjust a little bit. So don't get discouraged, if things aren't working out exactly in the path that you set forward, but as long as you keep your eyes on that end goal. And again, remember, there are multiple ways to get to your final destination. Obviously, engineering and science is very helpful in this industry, but it's certainly not required. Again, we have lawyers, we have accountants, we have procurement specialists, we have public affairs officers that are good at marketing or designing. So it doesn't have to just be a science and engineering background that can lead you to a really fulfilling career in space.
And Mark, what words of advice would you have?
Yeah, very, very similar. I would tell people to follow their dreams, plan, prepare, study, always remain positive. How you get from A to B may not be how you originally planned, but there are a lot of opportunities in this industry. And as Laura said, a lot of it is science and engineering, but there's also a great deal that is outside the science and engineering realm. We hire a lot of technicians, we hire procurement folks, we hire accountants, we hire all business operations specialists. So a lot of opportunities, and if you want to look at some of them, you can check Axiom's website out digitally, and that'll give you a good feel for the opportunities that we have available.
Oh, fantastic. I'm also curious about where you see the private space industry and NASA going into the future. I mean, it is so exciting for the vision to ultimately send humans to Mars. And I think similar to John F. Kennedy's speech 60 years ago, he said, we're going to send a man to the moon and bring him back safely in 10 years with technology yet to be invented. So I know there are a lot of things that we're still trying to figure out, but what are some of the challenges in developing a spacesuit or even a Mars walking suit? What are some of the differences between what you're preparing for the moon compared to Mars? Are there some other kind of special considerations for suits for Mars?
So going from the moon to Mars, again, you're on a planetary body. So you will be in a gravitational field. The gravity is even stronger on Mars. But again, we have made such advancements in the mobility elements. We're well on our way there. The biggest difference is that Mars has an atmosphere. And so the technologies that we're using in the vacuum of space on space station and on the lunar surface will not necessarily work on Mars where there is an atmosphere. So those are going to be some of the bigger changes in the life support system. And then, of course, when we're on Mars, we're much, much farther away and we have a more significant communication delay. And those crews are just going to need to be much more autonomous than space station or even the lunar crews. So the suits are going to have a lot of self-diagnostic capability, again, high reliability, because those crews are going to be out there a long time by themselves. The suits will need to be easily maintained so they can change components that have either worn out or have passed, an operational life. But it's going to be about being farther away for a longer period of time.
That's absolutely fascinating, because I hadn't considered that Mars does have an environment, right? The different mix of gases, and what does that mean for interaction with the material of the spacesuit, and other, or residuals coming inside of life support area where astronauts are living. Those are really, very, very big questions that have to be contemplated. And also just the soil composite, right? You've got the regolith of the moon, but we're learning more about the surface of Mars, right? As we're collecting samples. And, the samples we know right now are those that have traveled millions of miles, right, through the atmosphere and have been affected probably by their transport, by asteroids or other things. But it's going to be fascinating when we get those core samples back from the rovers and better understand really what is there on the surface of Mars. We have some understanding, but we're going to learn a lot more. So interesting. Well, I guess I wanted to see if you had any final thoughts that you wanted to share with our viewers today about spacesuits being developed for both EVAs and for the moon, as well as the rovers that are being developed for the moon.
Yeah, this is a really super exciting time to be in the space industry. It's very different than it was even 5 years ago. It is really exciting to see the momentum that's being built in U.S. commercial industry, but also in our international partnerships. I think NASA's role is very different than it was historically, where NASA was the one that was doing all of the executing. I think our role now is we do some of the executing, but we're also about bringing everyone together with a common vision, a common architecture, getting everybody rowing in the same direction. I think that is going to brings some challenge with it. Just because we have so many people working together, it's going to be an integration challenge, but it's a wonderful opportunity that we have so many people involved and part of the program now. And I think, just a spacesuit, it's really interesting. People personally just identify with a spacesuit. I don't know if it's because it's worn by a human being or because it looks so human, but people really identify personally with a spacesuit. So being able to work on that, I can't wait to be sitting in mission control when the first boot goes down on this new spacesuit, right? I'm sure it's going to be another iconic picture for the first time this new suit steps on the surface of the moon. So really looking forward to it.
And Mark, do you have a final thought that you'd like to share?
Yeah, I would just agree with Laura that this is a really, really exciting time in space travel. And I never really thought that a commercial company would be building a spacesuit for NASA's mission, and we are just so excited and honored to be part of that. And in the coming months, we'll show more and more images of our spacesuit design. But as I said, we are really proud to be part of this mission.
Well, I have to say, I agree that people are fascinated by spacesuits. Space Center Houston's fortunate to have one of the largest exhibitions of suits, and they're extremely popular. And I think they provide people with some vicarious experience. They imagine themselves donning the suits. And I think many of you have seen that we have one that guests can stand behind and take a picture. And it's one of the most popular images that they capture because it really, I think, embodies exploration, and it embodies innovation and inspires people to think of what's beyond what they know in their lives. So I want to thank you both for the incredible work that you're doing to advance innovation and exploration and playing such a critical role to enable humans to become a multi-planet explorers, because we can't do it without these spacesuits that fit on our bodies, enabling us to explore. We'll look forward to keeping tabs on the work that you're doing and seeing the advancements in spacesuit design that are going to help enable the Artemis program to be successful in future missions. So I want to thank everybody for joining us today, and a special thanks to our panelists for such a fascinating conversation. If you'd like to learn more about this topic, follow Space Center Houston on our social media blog and check us out at spacecenter.org.